Hello, dear colleagues. How are you doing?
Fine, thank you.
Hello, Dr. Faden. We're good. How are you?
Good to hear from you, Ms.
Hello,
Hamza.
Dr. Faden. How are you?
I'm very good. Nice to hear you guys. Okay.
Good afternoon, Dr.
I don't see
Faden, dear
my
colleagues.
picture, right? You
Good
don't see my
afternoon.
picture.
Rula, we cannot see your picture, no.
Okay, okay.
Unfortunately, Dr. Vladimir is has something to attend, so he will not join from the start of the meeting. So when the time goes 12:30, we will begin.
Hello, Dr. Faden. How are you?
I'm very good, Dr. Basayer. How are you doing?
I'm fine, thank you.
Before we begin, let me ask a question. Is anybody familiar with SPSS from the audience?
I got familiar with it 22 years ago. But I-
Yes, I
years
am
ago.
familiar with SPSS, Doctor.
Okay, that's good. So for those that you are familiar with SPSS, that will be a very good revision. For those who know nothing, also it will be fine, because I will assume that nobody knows how to use SPSS.
What happened, Dr. Faden, with the license? Do we have enough?
Yes, we managed to get 2 licenses, one for me and one for Professor Alper. So thanks God, we are continuing. We will be able to deliver those trainings about SPSS. That was something
Yeah.
very positive. It was
But
approved.
I mean for everyone, students and faculty, no, right?
That one is under discussion. Still, we want to, make a proposal and coordinate with Dr. Farid, and hopefully we will be able to maybe get it.
Yes, hopefully, yes, yes.
Okay, since it is 12:30, let's begin. Okay, the learning objectives for this training session is about how we are going to use the basic functions of SPSS. We will learn how we can define the variables, how we can enter data from the questionnaire into the SPSS, how we insert and how we delete variables, how we save and print the SPSS file, how we can recode variables, how we can compute new variables, how we select and sort cases, how we split the SPSS file, and how we find cases. Well, basically, this training refers to after I completed my data collection process and I have my data. How I'm going to enter this data into the SPSS? I'm going to use a specific handout, which at the end of the lecture, I'm going to give it to you. It's a handout which I developed. Now, but before we proceed with SPSS, we need to see the different types of questions that we might have in a questionnaire. It's a very quick and brief revision from the previous lecture. And then we will discuss how we can input the answers for each of those questions into the data matrix of SPSS. So the first question we have here, this is an example, a sample of a questionnaire. How many cigarettes do you smoke per day? This is an open-ended question. And can anybody remind me what is the scale of measurement from the previous lecture? Is it nominal, ordinal, interval, or ratio? I assume better not to ask questions, eh? Okay, let me assume that you don't remember what we discussed in the previous time, but it's very important to know what is the scale of measurement of each question, because this will help you to correctly define the variables in SPSS. So just to remind you, this is a ratio scale of measurement. This is a ratio scale of measurement. The second question is a very typical question which has 4 items here. Please indicate the degree to which you agree or disagree with each of the following statements about tobacco packaging warning messages. So the consumers have to read those 4 statements and they need to indicate their level of agreement or disagreement on those 4 statements. Now, when time comes, we will see that in SPSS, we will be putting numbers, not words. So basically, we would be coding this type of question by using those values from 1 to 5. And as we said in the previous lecture, always 5 goes to the positive characteristic. So if somebody strongly agrees with a statement which is positive, for example, tobacco warning messages are effective in reducing smoking among youngsters, this should mean that the 5 should go to strongly agree. Of course, you could use any kind of values, but we use from 1 to 5. This is an interval scale of measurement, Likert type question, because it asks the consumer to indicate their level of agreement or disagreement on those specific statements. So this is interval, if you recall from the previous lecture. Question number 3, how old are you? Again, this is a ratio scale of measurement. The consumer is going to indicate a number here. For example, he might say 23. Like in the first question, he could say, I smoke 5 cigars per day. So we have a concrete number, and this number is being measured in has a specific unit of measurement, 5 cigarettes per day, or 23 years old. That's why it is ratio. Then we have another type of question, gender, what is your gender, which refers to a nominal scale of measurement. We discussed about those different types of questions in the previous lecture, and we said that we need to give certain values. It doesn't matter what value you will give, but you need to make sure that we are consistent when you are coding. So we could say that 1 is for male and 2 is for female. Then we have another question. Please specify the areas, places in which you smoke. Now, this question is, of course, again, nominal because we have words, not numbers, but it has something special. It's a multiple choice question. So we need to discuss how we are going to code multiple choice questions. We code them in a different way than gender. Gender is a mutually exclusive question, which means if you are a man, you cannot be a woman, and vice versa. But in question number 5, someone can select more than one option. So the selection is not mutually exclusive. I can smoke, for example, at the same time at home and in the office. So we need to discuss later how we are going to code and enter the data for multiple choice questions when consumers can select more than one options. And then we have the last example, the example of an ordinal question. Please rank each cigarette brand in terms of your preferences. So here the consumer needs to read those brands and he has to assign, ranks based on his preference. So for example, this consumer here prefers brand A first, then C, and then B. Always we start with the lowest number as the most preferable. So 1 means the first, 2 means the second, 3 means the third, etc. So we have examples here of all the different types of scales of measurement. So the whole, coding process is going to be comprehensive. So we have 1 ordinal here. We have nominal multiple choice, 5. We have nominal mutually exclusive, 4. Number 3 is again mutually exclusive ratio. Then we have Likert type, and finally we have again ratio. 1 is it's exactly the same with number 3. By the way, if you don't understand something or you want me to revise something, you are most welcome, to ask me a question directly. Don't raise your hand because I'm just viewing, my screen and I cannot see your digital hands. So let's move on to the SPSS now. Now, the first thing that you need to check when you enter into the SPSS is you have to go here on the right down corner and make sure that it says IBM SPSS Statistics Processor is ready. And you have this green tick. If you, by the way, this is SPSS 29. Well, to be honest, since Dr. Adri said I used SPSS 20 years ago, I have to tell you that when I did my PhD, I used version 8, and now we are in version 29. So you might, if you have different versions, you might see different messages. But the latest version, this is the one we are using now, version 29. You need to see this green tick. In the past, it was saying SPSS processor is ready or available. You definitely do not want to see here SPSS processor is not available. This means that you cannot conduct any form of analysis, and most probably you are getting this message because you don't have a valid license. Okay, this is the first thing. Now, SPSS has two main views. The variable view, where we insert variables, we need to define variables here, and the data view, where we insert the data, the raw data. Now, always we begin with defining the variables, and once we defined all the variables, then we go to the data view and we start insert the data. So the first thing that we should do is we should create for every question from our questionnaire a certain variable. To save time, I'm going to, let me do the first one and then I can open the file. So how many cigarettes do you smoke per day? Cigarettes per day. This is the first question. So we could definitely define this variable as siga num. So we go here to the variable view always. In the name of the variable, we type siga underscore num. All right. Before we proceed with defining all the variables, we need to explain a little bit these columns. So you will be correctly defining and inserting the data in the variable view. So as you saw, for example, in the name, I didn't use a space. I used an underscore. Why? Because SPSS has certain symbols which are allowed and certain symbols which are not allowed. So let's begin with the first column, the name of the variable. That is this column here, name. There are some rules that SPSS is using for you in order to define correctly the name of the variable. So each variable name must be unique. Duplication is not allowed. So if I try to create exactly the same variable, siga underscore num, immediately SPSS will tell me this variable name duplicates an existing variable name. So the good thing when you are making a mistake is that SPSS is explaining to you what the mistake is. So you cannot have a variable, two variables with exactly the same name. At least one character needs to be different. Then, okay, there are some limits depending on the size of the name. Another important rule is that the first character must be a letter or one of these characters. Subsequent characters can be any combination of letters, numbers, and non-punctuation characters. So first character must be a letter. So let me try to write 1, and then let's say siga. Now, when I click enter, again, SPSS is giving me an error message. Variable name contains an illegal first character. I used 1. We should start with a letter. Also, variable names cannot contain spaces or special characters. So instead of a space, you could use underscore to separate the words. So for example, let me try Siga num with a space. Siga space num, and now I'm pressing enter. Again, variable name contains an illegal character. So space is not allowed. Also, all these other special characters are not allowed. So these are the rules for the how you define the name. Avoid duplication and make sure you begin with a letter, and also make sure you don't use spaces or any of those symbols or special characters highlighted here. Now, the second column is the type. Now, here in type, we need to select what is the type of the variable. By clicking inside the window, you will see certain options. In case you would like to proceed with analysis of this variable to calculate some statistics, I always recommend to use numeric. So even if the variable is nominal, such as what is your gender, man, woman, still you will be using codes. So man would be 1, let's say, and woman will be 2. So still, even if you are measuring nominal variables, qualitative data, you will use numerical codes, and you will be inputting in SPSS numbers. So I strongly recommend that you use here always the numeric. Now here you can change the width of the integer part and the width of the decimal part. So if you don't want to have any decimals, you can just put here 0. Okay, we will see that also later on. Now, there are also some other options. For example, sometimes you need to specify the date, maybe that the data have been collected, or maybe a certain currency, or string. If you want to write, let's say, the name of the consumer, string refers to text. So you want to write words as answers. So for example, for an open-ended question, you could use this type of question, type of variable. So you can just copy the text that the consumer mentioned in the questionnaire. So this is the type. Then we have the width and the decimals, which I already explained. Width refers to how many characters a string variable can hold. And also, if the variable is not string, it refers to the number of digits displayed for numerical values. The decimals refer to the decimal part. So just to give you an idea, if I go to the data view and I write, let's say here, 5 cigarettes, you will see the 2 decimals. Why? Because I allowed to have 2 decimals. If I go here and I remove the 2 decimals, because you cannot have decimals in terms of cigarettes smoked, it should be an integer. So now, since I changed it, when I go to data view, you will see the 5. So you see that the 2 decimal points have been removed. Next one is labels. Now, in labels, variable view always, in the label, we are allowed to use any kind of symbols, numbers, characters, text that you would like. So although there are specific rules and constraints when you are defining the variable, also in terms of the size of the name, here in label, you can write whatever you want. For example, you can say that this variable is about how many cigars consumers smoke per day. You see, I'm using spaces with not having the need to input underscores. I can use any kind of symbol I want, I can do whatever I want, and nobody will say anything to me. So this is the label where the researcher has the ability to write a description about what the variable is. So that is the label. Then we have a very important column which refers to values. Now here we mainly use this for nominal variables, although we could also use it for interval variables, but not for scale, for ratio variables, because it doesn't make sense. Let me tell you how it works. Imagine that we have another variable, and this variable is gender. As we said, we will keep it as numeric, although it is qualitative data. It's referring to words, man and woman, because we're going to use codes. So I remove the decimals. Okay, and here, when I go to values, I have the ability, when I click inside the box, to define what is the code for man and what is the code for woman. So based on my previous coding process, we said that male refers to 1, female refers to 2. So you insert the value 1, and you say that this describes men. Then you add again, and you say that number 2 describes women. So now you correctly coded and inserted the values of the variable gender. Okay. So for example, if you had, let's say, another variable, what is your preferred color? And you have, let's say, a list of 10 colors, you would write here a preferred color, preferred underscore color. And then when you go to values, you will introduce, let's say you have 10 colors. You will need to use 10 times this sign, and you have to say 1, for example, gray, 2, black, 3, red, etc., until you complete the whole list of colors. So this is very useful when you code nominal variables, words, in other words, where you allocate a specific label, a specific code to each of those words. Let's check the next column, missing values. Now, missing values is something very important in your data. Unfortunately, there are always missing values, and statistical theory recommends how you should treat when you have missing values. Now, this column here of missing values gives the ability to the researcher to describe even different types of missing values, because when a respondent is refusing to answer, this is one type of missing value, where, for example, he leaves empty the box, he didn't tick anything. Another potential type of missing value is something related to that particular question did not apply to that respondent. If you read my notes from the previous lecture, there are some certain questions which we call them screening questions, and those questions are trying to identify a special characteristic for the consumer, and based on that answer, they might request the consumer to skip certain type of questions. For example, you might say, if you smoke, if you are not a smoker, please go skip question 2 and 3 and go to question 4. That means that the consumer shouldn't answer questions 2 and 3. Why? Because they are not applicable for him. So not applicable is a missing value, but it's totally different from a respondent who refuses, let's say, to respond. So in SPSS, we have the opportunity to define missing values. So here, the missing values. So when we go to, let's say, gender, for example, and we click on the box, we have the option to select that there are no missing values, which is not recommended. And then we have the option to either select discrete missing values, where here we can define 3 different values, which will describe 3 different types of missing values. Now, usually we use 9s. For example, I could use here 9 and 99. And I could say that 9 refers to the respondent refused to answer the questionnaire, and 99 refers to not applicable. Or I could also select a range of values from low up to high. For example, in question about the attitude towards tobacco warning messages, the valid range of values is from 1 to 5. So I could go into SPSS, and for that particular type of variable, I could say any value above 5, so from 6 and above, should be considered as invalid. So if I want to do this, then I have to select what? The range. So I would say from 6 until a very high number. You can put as much high as you want. Okay. Consider that those values as entry mistakes. So SPSS will not calculate it, because if there is any big value which is above 5, 5 is from 1 to 5 is the valid range of the values, then this means that, and if you don't define it, then SPSS will count it as a valid value and will damage your mean, your median, all your statistics. So let's suppose that for gender, we want to use discrete missing values. So we could say 9, he didn't complete, and 99, not applicable for him. Of course, that's not the case, because gender should be applicable for him, but this is just for demonstration. Still, you can go to values and say that value 9 is no answer. He didn't answer. And for example, 99, not applicable. So in values, you can always define the codes of the missing values, and of course the codes for the valid values. Okay. Any questions so far?
All good, Professor.
Okay. So this is how we treat missing values. Now, the next column is referring to columns. As you will see here, columns specifies the column width for the display of variables in the data editor. Not a very important thing to know. Note that this is not the same as the number of digits displayed for each variable, like the width. This simply refers to the width of the actual column in the spreadsheet. So you will see, for example, if I go to this variable sigma num and I increase the size of it, then you will see that when I go to variable view, you will see that the size of column increased. So basically it has to do with the size of the variable in the data view set. So if let me bring it back, you will see that this number will drop. Okay, align is very easy like Word. You have 3 options to align left, right, and center. Very easy like Excel, only for aesthetics. And measure, very, very important. Why? Because measure refers to the scale of measurement. So you need to make sure what is the nature of your variable. Here we have 3 options. We have nominal, ordinal, and scale. Remember, nominal refers to words that do not have any quantity implied. Ordinal refers to ranking, and scale refers to both interval and ratio. If you don't know what I'm talking about, you need to check my video of the previous lecture where we fully explained all those concepts, and we provided examples and we identified the differences. So as you can see here, interval and ratio are treated as the same quantitative data, because basically you can calculate any kind of statistic that you want. Remember, for nominal, we said mainly percentages, the mode and percentages. For ordinal, the best technique to use for descriptive statistics is the median, not the mean. For scale, which means interval and ratio, you can calculate anything you want. So for example, sigma num should be scale, gender is nominal, and prefer colored. If they just tick, then again, that should be nominal. The last one doesn't really play a very important role, although it is called role. Now here, the role that the variable will play in your analysis. So here you can define if a variable is an input independent variable or a target dependent variable. There is no need to make any selection at this stage, because later on when we will teach you, me and Professor Alper, how we can do some regression analysis, we can define there at that time which variable will play the role of the dependent or the independent. So I would say you just keep it, or you can put none if you don't mind, whatever you want. It doesn't really matter. Okay, so after we discussed about the all the columns of the variable view, let me now open an SPSS file that I created, and this SPSS file refers to the questionnaire we developed. All right. So let's go back to our questionnaire to see in full details how we inserted everything. First question, how many cigarettes do you smoke per day? We this. So as we said, we will define it as sigma num. All of them, as you see, are numeric. That is also numeric. I removed the decimals. I also inserted a label, number of cigarettes. Well, when the variable is ratio, there is no need to insert values. Why? Because it doesn't make sense. Here, you will have to just enter a number in SPSS. So if somebody tells you, I smoke 5 cigars per day, you just enter in the cell 5. You don't have to go here and say 1 means 1 cigar, 2 means 2 cigars, 3 means 3 cigars, etc. It's totally irrelevant. Why? Because we are entering numbers. So when you are entering numbers into the cell and those numbers are measured in a ratio, there is definitely no need to define values. None, I didn't put any. Now, look what I did in the missing variables. I said that it might be invalid for a simple consumer to smoke per day 100 cigars and above, and I just put a big number here. So any answer above 100 should be considered as missing value. In other words, it will be excluded from the analysis. This is just to protect my data from somebody who wants to make fun, or from someone who, maybe someone who is inputting the data into the SPSS. He made a mistake. He typed a couple of zeros more than the actual answer of the consumer. Okay, alignment columns, we don't care, but we need to make sure that this is a scale measurement because it's ratio. And we said the ratio and interval should be defined here as scale. Then we have the 4 warning messages. Let's have a look at them.
Dr. Faden, can I ask a question?
Yes, anytime you are allowed to interrupt me, please.
Thank you so much. So my question is about the missing values. As you said, those above 100 does not make sense, so we consider them missing values. But what does it mean when we say invalid? So is that the same meaning? Because I heard you also say that. Are they two different concepts?
Look, invalid means that the answer is the option the consumer selected or wrote, or the person who coded the data inserted in SPSS is not correct. So, for example, in question number 2, what is the valid range of answers? From 1 to 5, right?
Yeah.
So, in that case, the respondent will not make a mistake because you force him to select. So if he doesn't select anything, he leaves it empty, then this is a missing value. You will code it as 9, no response.
Yeah.
And make sure that 9, when you define this 9 does not fall inside the valid range of values. For example, you cannot define, a 3 as a missing value because 3 is a valid value. Now, but when, let's say, a researcher is taking, the questionnaires, which were completed via face-to-face interviews, personal interviews, and when he's inserting in Warn 1, he puts a 7 or an 8 by mistake.
Okay.
That is
So
an
it's not a
invalid
user
answer.
mistake, it's our mistake.
Our mistake, yes.
Okay.
In that case, could be our mistake. Okay. In some cases, in the example I gave you at the beginning, somebody might tell me here I'm smoking 500 cigarettes. Are you going to consider this as a valid answer?
No, so this is a missing information.
So this is not our mistake. This is
the participant's mistake.
The participant's mistake, exactly.
Yes.
So
but when we say invalid, it's our mistake.
Also, that answer is invalid from the participant side. It's not real. Invalid means not real.
True.
It means that should be treated as a missing value, should be excluded from the analysis. Because if we include it in the analysis, it will ruin our means, our medians, our analysis.
Absolutely. Yes,
okay?
Clear. Thank you.
So
yes,
both can make mistake. The first example is the mistake from the respondent because he wants to make fun or he mistyped, whatever. The second mistake is the person who is entering the data into the SPSS by putting a 7. So I can protect from both mistakes by going here, and for every single variable, you see, for the next one, Horn 1, I said any value from 6 and 19, consider it as missing value. You see? Why? Because only from 1 to 5 should be considered as valid values.
Yes,
so if somebody makes
clear.
It's clear. Okay.
Yeah.
Good.
Thank you.
Good. Welcome. So let's go back to the questionnaire. We have here, please indicate the degree to which you agree or disagree with each of the following statements about tobacco packaging warning messages. These are the messages that you can read them in on the packets of the cigarettes. They are very, horrifying messages with some very bad, images, scary images. They try to scare the consumer not to consume. Anti-marketing, and still you see smokers still smoke. Thanks God I'm not a smoker, and I hope you are not smokers. And if you are smokers, try to reduce it or even stop it for good. So here we are trying to measure the attitude of consumers about those warning messages. So we have 4 statements. Tobacco warning messages are effective in reducing smoking among youngsters. Tobacco warning messages do not respect my right to smoke. Tobacco warning messages must appear, etc. So we can easily say that all these could be defined as Warn 1 for the first statement, Warn 2 for the second statement, Warn 3 for the third statement, and Warn 4 for the fourth and last statement. Again, all of them are numeric because we will be entering numbers from 1 to 5 as per the coding we agreed. And okay, you can always in the label mention exactly what is being measured, effective for youth, not respect, they must be displayed on the package. So here you are describing the statement in those label lines. Then in the values, what do we have to do? We can definitely leave it as it is, because one means one, as long as we know that one refers to strongly disagree. But it is recommended for interval variables to insert the values the way I did here. 1 means totally disagree, 2 disagree, 3 neutral, 4 agree, 5 totally agree, as per our codings here in the questionnaire. 1 strongly disagree, 2 disagree, 3 neutral, etc. And once, just to give you a quick shortcut, once you selected and you defined for 1 or 2, simply right click, copy, here, paste, all variables are pasted. You don't have to type again all the values. Once you create one and all the rest variables have exactly the same coding, then you just copy and paste in the cell. It's like Word. It's very, convenient. The same stands for missing values. All right. So we finished with the coding, with defining the variables from Horn 1 to Horn 4. Let's see what is the next variable. Next variable is age. How old are you? And we need to, the answer is a number. So we just put age here. We remove decimals, doesn't make sense. No need to insert values, because if somebody writes his age 53, this means 53, nothing to define about it, nothing is wrong, and it's scale. And the last one is sex. Sex refers to the gender of the respondent, the label, and here we have values as we defined previously, 1 for man or 2 for woman. It doesn't matter, you can use any kind of codes. Okay, but for simplicity, you use 1 and 2. Don't forget that this is a nominal scale of measurement. Now, let's move on. Before we discuss about how we code 5 and 6, let's try to see how we are going to input the data for the first 4, because 5 and 6 are special, have some special conditions to consider. So here, it's like Excel, you insert numbers. So you have in the data view, now we moved away from the variable view, we went to data view here. In the data view, we insert data and we can view the data. So if the first consumer answered 15 cigarettes, you insert here and you input 15. The second 30, the third 5, etc. So consumer respondent number 9 is smoking 45 cigarettes. Okay. Then, based on the answers of the consumer, the first consumer said that he gave a 4 to Horn 1. 4 to Horn 1 means what? That he agrees. He agrees, a 4. If you prefer to use, when you are inputting the data, you could use also the values. So by just clicking here on this button, you can switch between the values that you defined previously and the codes. Okay. And with this, you are inputting the data. So for example, sex, nominal, 1 is for what? For men, we said. So we know that this guy is a man. Number 3 is a female. So we check what is the value in the cell, and then we see who is the respondent. Now, respondent number 1, number 2, number 3, number 4. Now, when you are conducting, let's say, face-to-face interviews and you use a hard copy of the questionnaire and you give it to the consumer fills the questionnaire, and then you get it back. The first thing that you have to do is you need to number the questionnaires. So let's say you have 100 responses, 100 questionnaires in front of your desk. You need to put codes to every questionnaire. So you need to say questionnaire number 1, number 2, number 3 in the first page of the questionnaire. So you know what is being recorded. So this refers to the first questionnaire, this to the second, this to the third, etc., etc. Now, in some occasions, you will see if you are using, for example, online data collection platforms, that you will be getting the data in an Excel, let's say, format. And usually that Excel format has words. You need to use the function of find and replace. And using this function, you put find, you select a word. So for example, you say find agree for that particular variable and replace it with for. Find neutral and replace it with free. So at the end of the day, you transpose, you convert all the words into numbers. Then you copy and paste those numbers and you put them here. You can easily copy and paste from Excel into SPSS. But first, if Excel is using words, you need to convert those words based on your coding system to numbers. And then you copy and paste the numbers and you put them in the data view of SPSS to proceed with your analysis. Consumer number 9 is 56 years old. He smokes 45 cigars. He's neutral for horn 1. He disagrees for horn 2. He agrees with horn 3. He disagrees with horn 2. And he's a man. This is how you can read the data based on your codings. You need to be very well aware of the codings. Okay. Now, let's see how we code question number 5. Question number 5 is a multiple choice question, and we said that if I use the traditional approach, like I coded gender, I have the following issue. What cell, what number I'm going to put in the cell? If, let's say, for example, somebody might say, okay, let's, professor, do at home 1, in the office 2, outdoors 3, entertainment 4, and other 5. But it's a multiple choice. So someone can smoke at home and in the office. Unfortunately, if I do it that way and I go to data view, and let's suppose here is smoking place. Let me give it. So smoking place. And here I can define the values. In order to save time, I'm not going to do it. But imagine we proceed with this approach. So when I go to data view, smoking place, I can insert only one number. I cannot insert 2 numbers. I cannot insert 1,2. No, that's not valid. This means 1.2 or whatever. No, I can insert only one number. Any ideas how we can code multiple choice questions?
More than one answer allowed?
When all no, you can select multiple answers, so not only one, but more than one. But unfortunately, in the cell, you cannot put only one number. Previously, in gender, it was easy. I told you, are you a man or a woman? If you are a man, we insert 1. If you are a woman, we insert 2. Now the problem is that we need to, we allow the consumer to give more than one options. So that's not a good way to code the variable. We have to delete this to clear it. Right click, clear, it deletes the row. Right click, clear here. Now, the best approach is what you do. You go into the your questionnaire and your coding, and all the 5 options that you have, you make them variables. You call them as dummy variables with 0 and 1. 0 means not selected, 1 means selected. So basically we have home, office, outdoors. So I create home,
Dr. Frieden, or you could actually go to analyze and then just put multiple responses.
The thing is how we are going to input the data into the SPSS. You see here, home office, outdoors, outdoors, and let's say what else we have, entertainment and other. Entertainment, other. Okay, so now we go to values and we say 0 means not selected. 1 selected. Okay. And copy and paste for every single variable. Let me remove decimals because the values are 1 and 2. So now, if a consumer said, I'm smoking at home and outdoors, you go to SPSS, data view, the first consumer. He smokes at home and outdoors. He smokes at home, 1. Outdoors, 1. Office, 0. Entertainment, 0. Other, 0. So that's how you insert the data for a multiple choice questions. And then you can, if you want to calculate descriptive statistics, you can do it per variable created here. So let's say that the second consumer smokes in office and in another place. 0, in office he smokes. 1, he doesn't smoke outdoors, he doesn't smoke in entertainment, and he smokes at another place. So this is how you code multiple choice questions. And then the next thing we need to see is how you code ordinal questions, ranking questions. Because again, you have the issue, if you create only one variable, how you are going to use, let's say, the 3 numbers as per consumers' responses. So for example, if I say here, preferred brand, I run into the same problem. What preferred brand? How I'm going to rank those preferred brands? So the correct approach is to mention, as we say, make the values and what is being evaluated as different variables. So you need to create here 3 variables. 1, brand A, brand B, brand C. And then put the numbers as per consumers' answers. So brand A, brand B, brand C. So here, when I go to data view, I will see that I have brand A, brand B, and brand C. So if, let's say, the first consumer preferred first brand A, then C, and then B, then we give the relevant value into the cell. So brand A is 1, brand B is, brand C is 3, sorry, brand B is 3, brand B is 3, and brand C is 2. So we have here the correct insertion of the answers of the consumers when the question is ordinal. So all these refer to multiple choices with many selections with 0 and 1s, and this refer to ordinal questions where you ask the consumer to rank. If you had 5 items to rank, you have to make 5 new variables. If you have 10, then 10 new variables, and so on. So we will see how we will analyze this data when we discuss about descriptive statistics. So now we need to move on to the second part, which refers to the basic SPSS functions. So the first thing that you definitely need to know is how to save a file. File, save as Word, Excel, as every single program. You click Save As. Note that SPSS output is using the SAV extension. Okay, the SAV extension. Now be careful if you run a quick analysis. No need to know what I'm doing now because we will explain next time, for example, in cigarettes. And you click OK. Here, this one is a different window, you see? It's a different window. The analysis, the output. It's called Statistics Viewer. You need to save it separately. File, save as with a different extension, .spv. Okay, so SPSS has different file names depending on what you want to save. You want to save the output, the viewer, SPV. You want to save the data metrics and the variable names. Here, that one, then SAV. And we will also learn about the syntax error, the syntax in a while, which also is a different, has a different type of extension. So that is one thing how you need to save. Also, another very important is how you can print. For example, file, print, as simple as that, and you click OK. Before you print, you can always check the print preview. So here you will see how it will appear. Let's say, basically, you don't want to print the data, you want to print the variables to see the codings and all these things. So you can print the variable view, file, print preview, so you can see here what is going to be printed, like Word. Okay. So now we will move on to some basic SPSS functions, which are very important for you when you are first being introduced with SPSS. The first very important function is the recode function. Now, there are certain reasons why you might want to recode a certain variable. Let's try to do task 4. What do you observe regarding the answering direction of the scales of tobacco packaging warning messages? Let's go and have a look at those, at the answering direction of those statements. Let's read the first one. Tobacco warning messages are effective in reducing smoking among youngsters. So if you strongly agree with this statement, which is positive, it means you agree that they are effective in reducing smoking, those messages. Let's read the second one. Tobacco warning messages do not respect my right. This is a positive or a negative statement?
Negative.
Negative statement. So if someone says, I strongly agree with something negative, this means that this statement has a totally different answering direction from the first one. In the second one, it means if he strongly agrees with this, he doesn't like those warning messages. In the first one, if he says strongly agree, it means he likes to see those warning messages. Do you understand the difference between 1 and 2? Let me read the third one. Tobacco warning messages must appear on the packaging of cigarettes. Must appear, again, is something positive, like are effective in reducing, positive. So if somebody says 5, strongly agree, it means he's happy to see those messages on the package. Let's read the fourth one. Tobacco warning messages will contribute in the long run to the reduction of tobacco consumption. Will contribute to the reduction, another positive statement. So again, if somebody answers 5, strongly agree, he's happy with the existence of those warning messages on the package of the cigars. So the only difference in terms of answering is horn number 2, that one here. So what we have to do if we would like, let's say, to add all those 4 items in order to create a general attitude towards tobacco packaging warning messages, and we would like to add those items. You cannot add apples with oranges. We have 3 apples here, the first, the third, and the fourth, and 1 orange. That orange must be recoded to an apple, because if we reverse the values, then we achieve consistency with warn 1, 3, and 4. In other words, if for warn 2, when I see a 5, I make it as 1. When I see a 4, I make it as 2. When I see a 3, 3 stays as it is. When I see a 2, I make it as 4. And when I see 1, I make it as a 5. Then I managed to reverse the coding of that variable, of that statement, and I managed to make it consistent with the answering directions of the other 3 positive statements. So this is something that you might want to do when you have certain data as a basic function. How we do it? We need to recode the variable. So we go to transform, recode. Now, we don't use it into the same variables because we're going to lose the initial variable. We want to keep it. So always try to record into different variables unless you don't care about the initial variable. Once you click there, you need to select which variable you want to recode. By just putting your cursor on the items here, you can see which one is what. So here I can see that warn 2 is the no respect. I select it and transfer it in the window on the right. SPSS is telling me you want to recode warn 2 to what? So I need to give another name. Warn 2, and I insert an R, recoded. Okay, since I'm using, I want SPSS to recode it into a different variable. This means that SPSS will keep the original variable, so I have to give a different name, because as we said in the beginning, you cannot have duplication of names for the variables. Here I can insert the label, which automatically will appear here in the label. Warn 2 recoded. I can use spaces. I can use any kind of symbols. I'm totally free to do whatever I want, while when I'm defining the name, all the initial constraints we discussed together in the beginning of my lecture apply. So I cannot have here a space. I need to put an underscore. And then I have to click change. So I'm telling SPSS to recode warn 2 to warn 2 recoded. Now I need to change the values. So I go to all the new values. And I'm doing exactly what I told you. Whenever you see 5 in the old value, in the new value, make it as 1 and add. Every 4 that you see in the old value should be converted to 2. Add. 3 to 3, that stays the same. Add, but you have to define it. 2 to 4 and 1 to 5. So you need to identify, to clearly give guidelines, recoding guidelines for all the values of the variable. Am I done? No, I'm not done. I need to always include system missing. So all the system missing values from the original variable, I want them to be exactly as the same as for the new value, for the new variable, the recoded. So basically, I'm copying the missing values. Add. So also I have the system missing, and now continue. So now I'm ready just to click in OK and see if the variable is correctly recoded. I click OK. I see immediately that this new variable have been generated. I go to data view, always go to data view to visually check if the coding is correct. Let me delete all these things because we don't need them. So warm 2 was here. Yes, the 2 became 4. 1 converted to 5. 2 to 4. 3 remained as 3, etc. I can definitely go back to variable view, remove the decimals because there are no decimals. Of course, this one is not nominal. It is scale, interval, as a matter of fact. So now I correctly defined the variables. You see also the label which appears here as warm2 recoded. So now I can use, if I would like to create a general computed variable, which is measuring consumers' attitudes towards the warning messages, I should use, instead of warm2, I should use warm2 recoded. So this is the recoding function. Let's see also another task related to recoding. Now, another task could be record the variable siganum, creating 3 groups according to the following. So another reason might be I have a ratio variable which is being measured in numbers, but I want to create certain groups and group by defining specific ranges the initial variable. So siganum, I want to create 3 groups from 0 to 15 and name them as light smokers, 16 to 30 as moderate smokers, and 31 and plus as heavy smokers. So what I have to do is I go again, transform, recode into different variables because I want to keep the initial siganum. I don't want to lose the information because if you put into the same here, you will have an issue. You lost your initial data and the initial information. So since I want to do some recoding of siganum now, SPSS kept the previous options. So what I do here, I just click reset to start again from scratch. Then I want to recode number of cigarettes per day. Again, I need to give a name to the new variable I'm going to create. Siganum recoded. I can put a label if I want, that's okay. And then we go to all the new values. So here we need to check what are the coding rules. From 0 to 15 refers to light smokers and should be recorded as value 1. So I go here to SPSS and I'm using the range option. So from 0 to 15 in the old variable, the initial, make it 1. Add. Next coding rule. From 21 to 40, make it 2. Okay. From 21 until, not 40. One moment. Sorry, from 16 to 30 is the second coding. From 16 to 30, make it 2. 16 to 30, 2. Add. And then the last category is 31 and above. Now, range is not helping me because I don't know what is the highest value, but I could say range value through highest. So I can enter here 31, and this means that from 31 up to the highest value. So SPSS will find the highest value and will give the code of 3. Add. So here I have all the codings. Am I done? No, I'm not done. System missing in the old one, system missing in the new one. Don't forget that. And then you add it, and now you are done. So if you click continue and change here, click OK, and you will see this new variable generated here for you. So you could check that from 0 to 15, we said it should be 1. There it is. From 16 to 30 should be 2. There it is. From 30, what was the coding? From 31 and above should be 3. There it is. So now quickly you can go even to variable view. You will see this new variable here. You can go to values, and now here it makes sense to say, for example, 1 light smokers, 2 moderate smokers. You can define your groups. 3, how you said it, heavy smokers. Okay, heavy smokers. Add. Okay. So when you see here all the values, when you go to data view, when you switch, you can also switch and see here what are the values for in which group every single smoker belongs to based on the number of cigars he's smoking. So we demonstrated 2 ways that we might need the recode function. The first one was to have consistency in the answering direction of the items of a general construct. And the second one was to create groups of initial ratio variable to create to make certain groups. Now, if we want to be 100% specific and correct, that new variable which is created is definitely not scale, it's ordinal. Why it's ordinal? Because the ranges we use to create this scale are not equal. 0, 15, this 16, you have 16 values here. 16 to 30, you have 15 values here. And here you have unlimited values, 31 plus. So you don't have equal distances. So if you recall from my previous lecture, it's not interval because the distances are not equal. Therefore, it is a little bit degraded. It becomes as ordinal. So if you want to be scientifically correct, you have to put here ordinal. Another task, and now we are going to use the syntax editor, something new. Here the tasks tells us recode sig and num, creating 3 groups again, like previously, but now we want different ranges. So from 0 to 20 light smokers, 21 to 40 moderate smokers, and 41 plus heavy smokers by using now the syntax editor. So what we need to do? We go to SPSS, we go to transform, recode again into different variables. But since now we want to use the Syntax, we don't click on reset to repeat the process and just change the ranges. We click on paste. When you click on paste in every window, the syntax editor is activated. Syntax editor means that you can use programming language, very simple commands, to tell Excel what kind of functions or techniques you want it to calculate or to perform. So what we could do here easily, we see what was the command line for the previous task we completed. The previous task said recode SIGANAM using these rules into SIGANAM R. So I could use the same command line here, and I can just go and change what? The ranges. So the new ranges are from 0 to 20, 21 to 40. So 0 to 20, 21 to 40, and I'm pretty sure it's 41 through highest. But not in SIGANAM R, because that is the previous variable we created. We want to create a new variable. So SIGANAM R2, recoded 2, for a second time recoded with different ranges. I select and I click on this green button here, run selection. Once I click on that, I go to SPSS, I see my new variable is already created, SIGANAM R2. I go to data view to check, and I see that I have a correct recoding. For example, 15 is as 1, like previously, 30 as 2. Okay, these are the same. Which seems to be different, 40. 40, a person who smokes 4 cigars, now he's being recorded as a moderate smoker, not as a heavy smoker, because I changed the ranges. So that was another example for you to see how you could use the syntax in order to recode a variable. Again, I can go here, I can remove, of course, the decimals for both variables, and that also should be ordinal. Next one. Next function. Are we good so far? We have 15 minutes, so I'm trying to make as much as possible from the time we have. All good so far?
Oh, good, thanks.
Excellent, thank you.
Okay, that's great. So the next function is the function of compute. Previously, we said that we would love to create an average total attitude, a construct which is adding the 4 Horn messages, Horn 1, Horn 2, Horn 3, and Horn 4. So compute the average total attitude of consumers about tobacco packaging warning messages. Now, how we are going to compute? So basically, to remind you, we have those 4 statements here, and we want to calculate or compute a new variable which will be the average attitude of consumers about tobacco packaging warning messages. How we can do that? Transform compute variable. By the way, since I discussed about syntax, here we have a third file. File, save as, not to lose your data. And you see that now the extension is .sps. So if you want to save the syntax, to use the commands for further analysis, you can save it by the extension .sps. Okay, I'm going to delete it because we will not be using it again. So we're about to compute, transform compute variable. Transform compute variable. It's the option here. So what we are trying to create, we are trying to create an average scale which is measuring the attitude of the consumer about those warning messages. So attitude scale. So this is my attitude scale. And now I need to give guidelines to SPSS how it is going to compute this scale. So we need to add, first of all, by selecting all the warn messages. That is the first one. Well, we add, to compute the average, you need to add all the items and divide by the number of the items. This is the mathematical meaning of the average. So I'm selecting warn 1, then not warn 2 because it has a different answering direction, but warn 2 recoded, right? I'm selecting warn 2 recoded. Then warn 3 plus warn 4. Since I need the average, I'm just inserting here parentheses using the keyboard and dividing by 4. So I'm telling SPSS to create a computed variable which is going to measure the average attitude of the consumers about tobacco messages using those 4 scales, but of course the recoded warn 2. So we are consistent, we are correct. And OK. Immediately SPSS created for you this new scale, this new variable. You go to data and you see, you visually check the data. So this scale, of course, has the same values from 1 to 5, like the previous one, but it's taking the average. So now we have the average opinion of the consumers about tobacco warning messages. Now, on purpose, and since Ms. Masuma asked me previously, I made one mistake. The mistake is that I see here a very big number. This number is invalid because the valid number of values for that scale should be from 1 to 5, like the original values, the 4 original values. Now, why we have this error here? I need to go and check what's going on with certain questions. For example, warn 3 here, I have this big number. That should be a missing value. But the question is, did I warn 3 here? Did I define 3 nines as a missing value? Let's go to warn 3. You will see that I made a mistake on purpose, of course, for educational purposes. 99. That shouldn't be 99. 19 is missing here if I wanted to be correct. So now I fixed it. So that problem here should disappear if I do again the calculation. So you go to compute variable. I keep exactly the same things here. Let me make another scale, general, so you can see the difference. And now you see in the new calculated variable, this is empty. Why it is empty? Because SPSS is not going to give you an average when a specific variable, warn 3, has a missing value. Similarly, as for case number 7, who case number 7 did not answer for horn 1. So in both variables, computed variables, SPSS is not giving you the average. Why? Because it needs to be consistent. It needs to find valid cases in order to make the computation of the new variable. 7 more minutes. Let's see what else we can say. We are almost there. Select cases. Okay. The select cases function in SPSS enables users to select specific cases of data according to a variety of user-specified conditions. So here, let's imagine that you are trying to select only light smokers, only the light smokers. So what is the command you need to use? Data, select cases. Why you might want to select only light smokers? Because you want to calculate descriptive statistics only for this group of consumers. So data, select cases. Data, here down is select cases. And we should use if condition is satisfied. Let's use the SIGA-NUM R, the first one. We could also use the second, which has different ranges. And we say, since in SIGA-NUM R, the code 1 refers to light smokers, I want the SPSS to select SIGA-NUM R equals to 1. I click continue and OK. And I see this is SIGA-NUM R. I see that the SPSS erased all cases or respondents who are not light smokers. So number 2 belongs in is a moderate smoker. Number 4, as you can see here, is a heavy smoker. So SPSS kept only the light smokers as per my guideline. You can also check that certain cases are selected by looking here on the down corner, right corner here, filter on, that the filter is on. Okay, filter on, it says here. So for example, if I very quickly want to run some descriptive statistics, now SPSS, for example, about the gender of the consumer, let's say. Well, that's not the correct, because we should use frequencies. Let's use, let's say, descriptives, not the gender, because gender is nominal. Number of cigars. Now SPSS will calculate the number of cigars, descriptive statistics for only 5 people from the sample, only the light users. So if you see, if you go back here, 1, 2, 3, 4, 5. So you have 5 consumers who are light smokers. So SPSS did the analysis only for this group of consumers. Now, in case you want to turn the filter off, data, select cases, all cases. So if you want to remove the filter, data, select cases, and here you click in all cases, OK, and now you will see that all participants are back to the analysis. So those lines have been eliminated. There is no selection, and here there is no filter on command. Split file. The split file command is used to break the data set into logical groups so they can be analyzed separately. So let's suppose that we would like to split the data file by gender, by sex. What we have to do, we need to go to data split file, organize output by groups. So data, split file here, organize output by groups. Groups are based on gender. So I find gender, I placed it here, and I click in OK. I see here down in the right corner that the command says split by sex. So if, let's say, I conduct a descriptive analysis about the number of cigars smoked, SPSS will give me two different results, one for men and one for women. So for comparison studies, that's a very interesting tool to identify, for example, which group of people smokes more. In our case, we see the mean for men is 28, the mean for women is 14. So men on average smoke more than women. And we had the ability to calculate this because we split the file in two groups based on gender, man and women. Then we have sort cases. This is just for visual purposes if you would like to sort the cases based on a specific variable. So data sort cases, we would like to use, let's say, the number of cigarettes that consumers smoke. So data sort cases, data sort cases here, based on the number of cigars. You see now they are not sorted. First 15, second 30, there is not sorting. So we select number of cigars. You can select ascending or descending, whatever you want. When you click OK, you will see that we selected ascending. So all the cases have been sorted in ascending order. And the last function for today, just on time, go to case. This is applicable if you have a large data set and you would like to find a specific case. You can either use this icon here, or you could click to edit, go to case. So, and SPSS will bring you the case you wanted. So edit, go to case, and let's say we want to SPSS to give us respondent 8. Immediately when I click go, SPSS put in the first row the 8 respondent. Of course, it doesn't make sense when I have only 10 consumers, but if you have, 5,000 consumers and you want to find case 1035, then that definitely can make sense. Why you might need to find this case? Because you want to go and see the answers. There might be an issue with the answers of that particular person. So, ladies and gentlemen, that was the introduction to SPSS. I don't want to take more from your time. Just one very general question, if you have any questions. Any questions? It seems we don't have any questions. All good. Thank you, Dr. Omina and Dr. Yamen. I highly recommend that if you have access to the SPSS, you could use this handout and you can, try to do all those steps by yourself so you get familiar with the that particular software. Thank you for attending this lecture. Since there is no question, I am going to wish you have a good day. And always, when you love statistics, you should try to, receive trainings on statistics. And the best way you should learn is when you do it by yourself. So with this, I say bye-bye to you and hope to see you again in the next session.
Thank you so much, Dr. Faden.
Thank you, Faden.
Thank you very much, Faden. Bye-bye.
Bye-bye, guys.
Thank
Bye-bye.
you, Dr. Faden.
Thank you. Thank you.
Doctor.
It's not clear my draft.